Hello everyone, my name is Mohit and I welcome you all to my YouTube channel. I hope you all are doing great. So this is challenge number 2 of solving DSA challenges playlist, and in this challenge I'll discuss an interview question on how to find nth node from the end of singly linked list. Okay, so let me discuss this problem statement in a bit detail. Okay, so if you see here, we have 5 node in this linked list, right? And head is pointing to this first node with value 1, and tail is pointing to this last node with value 5. So if you are asked to find last node of this linked list, it is simple. The node which is getting pointed by tail pointer. Okay, so that one is the last node. And if we are asked to find second last node of this linked list, then we need to output this node with value 4, right? But the only problem is we don't have any pointer pointing to this node. And we also cannot directly calculate one step behind from this tail pointer because this is singly linked list and every pointer is pointing to its next node, not its previous node, okay? So to answer this question, we need to find out a way and implement the same in code in order to find nth last node from the end. Okay. So similarly, if you see second case, the value of k is 4. K is nothing but n. That means we need to find fourth last node from end. So this is the first last node. This is the second last node. This is the third last node. And this node with value 2 is the fourth last node from the end. So the code which we are going to implement should return this node. So now I hope problem statement should be clear. Now let me quickly switch to Visual Studio Code in order to implement solution for this problem statement. Okay. Okay. So these are the two classes, class node and singly linked list class that we created and discussed in our last video in a very great detail. And there we created these two class along with the constructor and other different methods which will be commonly used while discussing problem on DSA. So I have explained these things in a very great detail. So if you have any confusion about this piece of code, then I strongly recommend to please watch that video first in order to get much clear picture. Okay. So we will directly start writing method to find nth last node from the end. So we will define this method and we will name this method as kth node from end. Okay. And since this is inside singly linked list class, so we will put self keyword and we need to pass the value of k. Okay. Now here I will discuss two methods. So let me name this method as method 1. Now, first point we have to consider is this k should be a valid number, right? So it should not be less than equal to 0 or greater than length of linked list. Okay. So we will write if k is less than equal to 0 or k is greater than self dot length. So in this case, what we will output? We will just print a warning message. Please enter a valid value of k. Okay. And we will return none. So we don't want to return any node here. Now second case is if k equals 1, it means we want to return last node from the end. So we will simply return self dot tail. Okay. Now for other different value of k, what we will do? We need to create a temporary last pointer which will point to that kth node and we will return that pointer. Okay. And this pointer will point to last node of this linked list, which is self.tail. And let's say if k value is 2, that means we have to return a node which is pointing to second last node. And what is the second last node? Second last node is the node which is pointing to the node pointed by tail pointer, right? So to achieve this nth last node, we need to run a while loop and we need to put some condition that we will discuss later. But for now, let me put it as true. Now inside while loop, I will create another temporary pointer. You will understand these things once we complete this code. Now this pointer, I will point to first node which is self.head. Yeah, so every time this loop runs, this temp pointer will start pointing to self.head, right? And then what we will do, we will run another while loop, which will check if this pointer dot next is not equal to temp dot last. So while this condition is true, I will move this temp pointer to temp dot next. Now, once we have got this temp variable from this while loop, we will assign this node to that value. So let's say for the first loop run, temp dot last was pointing to last node and temp was pointing to first node. So first node dot next is not equal to last node. So let's say we have linked list with number of node equals 5. So first node dot next, it will point to second node, which is not equal to last node. So temp will become second node. Then again, second node dot next is not equal to fifth node, which is last node. So temp will become third node. Then third node dot next not equal to last node. So temp become fourth node. Now fourth node dot next is equal to last node, right? So in this case, it will exit this while loop and then we will set this last node to fourth node. Okay. So when this first while loop completes, this temp dot last node, which was pointing to this last node, now it will point to second last node, which is fourth node in our case. Okay. But let's say value of k is 3. Then again we need to run this loop, right? So we have to run this loop for k minus 1 times. And at the end of every loop runs, we will decrement this value by 1. Now, let's say value of k is 3. Then ultimately temp underscore last node will point to third last node of the linked list. So we will simply return temp underscore last node. Okay. So our first method is ready. Let us check if this is working or not. So what I will do, I will initialize this class with value 1. Then I will append node with value 2, 3 and 4. Also let me append 5. So it will reflect the same scenario what we have discussed from our slide. Okay. Now let me print this value first. Okay. So we have created linked list with 5 node and the value is 1, 2, 3, 4 and 5. Now what I will do, I will comment this line and I'll call this function. So object dot this function name and let's say we want this second last node with value 4. So what I will do, I'll put this value as 2 and let me run it. Okay, so it is returning nothing because first thing is we need to print this value and then let me run it. So you see here it is returning a node object. Why? Because we are directly returning a node. We are not returning any value. So to check the value of this node, we already know that node class has a property called value. So we can check the value of any node by using dot value. So now let me run it. So you can see output is 4. That means second last node value is 4. Let me check for third last node. Value is 3. So in this slide you can see third last node is 3. So if I check value for k equals 4, it should output a node with value 2. So let me give k value as 4. See, output is 2. Okay. If k value is 5, that means we want to return fifth last node from the end, nothing but first node. So it has returned 1. Now, what will happen if we provide some inappropriate k value? That means out of range value. So in this case, let me provide value as 7, which is greater than length of linked list. And let me first return node. Okay, sorry, let me save this file. See, it is giving us warning that please enter a valid value of k and it has returned none. Okay, so it is working as expected. Now, only one point we need to observe for this method is, since we are using two while loop, so big O for this one will become n square, right? So time complexity will become n square order. So it is n square, okay? For method 1. Now let me discuss method 2. So in this method, what I will do, I will define slow pointer called self dot head and fast pointer as self dot head. So basically slow and fast pointer are pointing to same node. Now again, let's say if value of k equals 1, that means we want to return last node, we will simply return self dot tail, okay? And for other valid values of k, what I will do, we will follow the similar approach but in a different way. For this in range of k, so let's say value of k is 2, then I will move this fast pointer, which is pointing to first node for now, to third node, okay? So we will write fast equal fast dot next. And before that, let me first check if this node, that means self dot head, is none, then I will just simply return none because there is no node in the linked list. So in that case, we have to return none. And based on the value of k, first we set this pointer, and then we will run this while loop till this pointer points to last node. Okay. And in this while loop, what we will do, we will move both pointer to its next node. And in the end, we will just return slow pointer. Okay. So what it is doing, first we are moving this fast pointer k node ahead of slow pointer. So if k value is 2, we will move the fast pointer to this one, node number 3, which is 2 node ahead of slow pointer. And once we have set this value of fast pointer, then we will run this while loop till fast pointer reaches at the end. So before running while loop, slow pointer was pointing to this first node and fast pointer was pointing to this third node if value of k was 2. And then we have run this while loop till this fast pointer reaches to last node. Okay. So at the end of while loop, when fast pointer pointing to this last node, this slow pointer, which was 2 node behind this fast node, will ultimately point to this third last node from the end. Okay. So this is the approach. So let me save this file and let me run this code again. For value of k equals 3. Okay, so it has returned a node. Now in order to check the value of node, we have to write value. So what is the expectation? It should return node with value 3 for k equals 3, right? So if I run this, see, for k equals 3, it is returning node with value 3. Let me check for k equals 2. So it should return second last node, which is node with value 4. Okay. For k equals 4, it should return fourth last value, which is node with value 1. Sorry, 2. Fourth last value is 1, 2, 3, and 4. From the end is node with value 2. Okay. So it is working as expected. But the only difference here is, in case of method 2, we are not using nested while loop. So this time complexity will become the order of n. So first method was order of n square. Second method is the order of n. So of course, if we compare these two codes, this one is much more efficient in terms of time complexity. Okay. So these are the two different methods that we discussed in order to find kth node from the end. Okay. And we also seen what are the advantages of second method over first method. Okay. Okay guys, that's it for this video. Thank you so much for watching. We will meet in our next video with another interesting and potential interview question on DSA. So please stay tuned. Till then, take care and goodbye.